Hello and welcome to Why These Notes Explorations in Music Theory. Um, those of you who've been following this channel for a while may know that I named the series Why These Notes because I wasn't satisfied when I was told to sort of memorize that out of the 12 notes of the chromatic scale, these 7 notes were the major scale and these other 7 notes were the minor scale. I figured there had to be a reason those 7 notes. And I ended up reading really old books on music theory and, learning sort of where all of these notes came from. And it turns out actually that before even we had the 12 tone chromatic scale, we had the 7 notes of the major scale. So it's not like somebody took the 12 notes and selected these 7 out of them. We actually had the 7 sort of before the 12, and it's because we had those 7 people sort of figured out that there needed to be notes in between some of them, and that's how we got to the 12 note scale that we have today. And the story actually starts a couple thousand years ago with Pythagoras. Yes, the guy who figured out how equilateral triangles work. And the story is that he was walking around in the countryside and he passed a blacksmith shop. And the sound of the hammers hitting the anvil sounded good to him. It sounded melodic, it sounded harmonious. So he went into the blacksmith shop and he did a bunch of experiments on the hammers to try to figure out why, these specific hammers sounded good together. And it turns out that when he weighed the hammers that had whole numbered ratios of weights to each other sounded good together. So 1 pound to 2 pounds, 2 pounds to 3 pounds, and so on. This, by the way, is part of the reason we call it a musical scale, because the idea is you can literally weigh the notes. So he went home to his workshop and he performed an experiment with lengths of string. He would nail one end to a board and tie a weight to the other end. And the weight was to make sure there was equal tension on all of the different strings. And he would then vary the length of string by, where he placed the nail. And he would play them together, and the notes that sounded good together were different whole numbered ratios to each other. And here you can see Pythagoras with bells that have weights that are different whole numbered ratios to each other. And he's playing an 8 and a 16, 2-to-1 ratio, which is an octave. So I'm going to do similar sort of thing with you here. As you can see, there's a visual of a length of string going from left to right. I superimposed a guitar fretboard on top of it. So you could see, where all of the semitones would be. So starting on the right side, if you were to put your finger on any of those black lines, we would sort of shorten the string by that amount. So the length of the string is from the left side to, wherever we're stopping our finger on the fingerboard. And you can see the 2-to-1 ratio here is highlighted. That's the octave. Hopefully everybody knows that. Half of the length of string is an octave, which is also double the ratio. So if this is A equals 440 is the full length of string, 880 frequency, twice the frequency, half the length of string is the octave. T in this case means tonic because it is, we're building a scale. So that's 1-to-1, the full length of string. And 8VA means octave. It's half the length of string. So we have this. What is the next obvious place to go? 2/3. And again, you could see the grayed out section over here is the section that we're not ringing out. So 1/3 of the length of string is the musical fifth, the diatonic fifth. And because anytime you sort of double a length of string, it's the same note in a different octave. We could do 1/3 or we could do 2/3. In this case, we're doing 2/3 of the length of string is the musical fifth, 2 to 3. By the way, one of the most frequent questions I get here is, why, what do you mean when you say a fifth is 2 to 3? And then what do you mean when you're adding 2 notes together? Why do you multiply? So we're going to answer these questions. So the next obvious place to go from here would be from 2 to 3, we go to 3/4, right? We have 2/3 of the length of string. But I want to point out that we already have that interval. We've already discovered this interval because, as we all know, the distance between a fifth and the octave is a fourth. So we could actually just sort of calculate this here. And as we can see, 3/4 of a length of string is the musical fourth. So if we start from the fifth, 2/3, and then we take 3/4 of that, we get the octave. So 2/3 times 3/4. 2 times 3 is 6. 3 times 4 is 12. So that is 6/12, or 1/2 is the octave. So we've already discovered sort of the musical fourth this way, but that doesn't actually give us the location of the fourth, on our full length of string. So what we do is we take that, that ratio that we've discovered and stretch it out to the full length of string, 3/4. We now have the musical fourth. And I want to take this moment to appreciate that we have all of the perfect intervals now, right? You might think of the perfect intervals as, quote unquote, the ones that are neither major nor minor. To me, the perfect intervals are the fundamental building blocks of the major and minor scale. In order to build the major scale, the way I describe it is you play a major chord on 1, 4, and 5, and that is how you build the major scale. So these are the most fundamental building blocks. The next thing we need is, of course, 4/5, the major third. And now we have every single ingredient we need to build both the major and minor scales. So something I would like to point out, in the same way that when we discovered the fifth, we took the distance between the fifth and the octave to derive the fourth. We take the distance between the major third and the fifth to derive the minor third. So the minor third here you could see is 5/6, that ratio perfectly exists between the major third and the fifth. So again, we perform the same trick and we stretch it out, and we now have the minor third as 5/5 of the length of string. We're going to disregard the minor third for a while because we're just building the major scale. But here we already have all of the ingredients we need to build the major scale. I'm just going to hide the octave here to make it a little easier. So we have the fifth. What happens if we want to figure out the major seventh? Well, as I said, building a scale is basically building a major chord on 1, 4, and 5. So let's do that. If we want to build a major chord on the fifth scale, we need to add the major third. So the major third is 4/5 of a length of string. We're already at 2/3, so we multiply the numbers together because we're sort of multiplying fractions to get a smaller segment of string. So 2/3 for the fifth and 4/5 for the major third yields 8/15. 2 times 4 is 8. 3 times 5 is 15. The major seventh happens at 8/15 the length of string. And of course, you may know that the major second, the second is known as the fifth of the fifth because it is literally the fifth of the fifth. We take 2/3, a length of string, and again, we multiply it out by 2/3 of a length of string, and we get 4/9. 4/9 is above an octave. It's less than a half. So in order to pull it down, to the useful location as the second, we sort of just multiply that 4 by 2 to get 8, and we get 8/9 is the major second. So the last note that we need to derive is the sixth. And again, we're going to start with the fourth and build a major scale on the fourth. We add the major third to the fourth. So 3/4 of the length of string multiplied by 4/5 of the length of string is 12/20 of the length of string. 3 times 4 is 12. 4 times 5 is 20. 12/20, you could simplify that to 6/10. So now we have all of the notes in the major scale. We don't need to add a fifth to the fourth because we already know that that's the octave. But if you wanted to do that, that would be the octave. So we have the tonic, the octave, we have the fifth, we have on top of the fifth the major third, we have on top of that the ninth, which is the second. We have the major third, we have the fourth, we have the sixth. We now have the entire musical scale: tonic, major second, major third, fourth, fifth, major sixth, major seventh, octave. And again, the perfect intervals, 4 and 5, are perfect, not because they're neither major nor minor, but it's because they're the fundamental building blocks. We build a major chord on the tonic, 1, 3, 5. We build a major chord on the fifth, 5, 7, 9, which is also the second. And we build a major chord on the fourth, 4, 6, and octave. And that is how we build a major scale. All from simple ratios, and you could see there's only a couple of times where we sort of have to add numbers together in order to derive other notes. And then, if we want to turn this into a minor scale, we would simply add a minor third to the tonic, the fourth, and the fifth to derive the locations of the minor scale. I'm not going to do that here, but you can imagine that that's how that might happen. And then to get to all 12 notes in the scale, you just perform similar operations. This is the way music was for thousands of years. This is the way music was, and it's only recently that we have these sort of 12 chromatic notes that we consider to be like the 12 notes, and nobody questions them, and you sort of have to memorize which 7 out of the 12 form the major scale and the minor scale, 12 major keys and 12 minor keys. But this is basically how you build the major scale, basically from a few fundamental building blocks. Why, when I say you're adding a fourth to a fifth, you're actually multiplying. It's because you're taking a fraction of a fraction and you're multiplying that out. So hopefully this has been helpful to you. This is, my first video on this channel in something like 6 years. It's a topic I've wanted to cover for a while, and I have in various ways, but I think this is sort of the easiest, hopefully, to understand. It explains everything, hopefully cleanly. I hope you guys understand at least things a little bit better. If not, leave comments. I respond to most of my comments that are, where people are asking questions. And I'm hoping to add a few more videos in the future, not too many. But, if you want them, go ahead and subscribe. Thank you for watching.